So here we have a alternator that I purchased at Advanced Auto Parts, somewhere around 50 bucks. And we have the ground connection here, black. We've got the power connected in red here. There's some internal regulation happening in here, and I wasn't sure about it, so I put a diode, like a 6 amp diode on the end here, but when I test from both locations, on the end of the diode or before the diode, it seems to be the same waveform. So the way this thing works is I have a 12 volt power supply here hooked up to a switch, which is that little red switch right there. So when I momentarily turn that on, it'll send 12 volts to the alternator, which will in effect turn on the electromagnet, and then when I pedal, I will be producing about 14 volts. The first thing I do is I turn on the display. See, there's no voltage here. When I hit the switch here, it's going to send 12.4 volts into this alternator. Now the magnet's on. I'm generating 13.6, 13.8, 14 volts. Now I'm going to shut this thing off. There's no battery now in the circuit at all. So all this power that I'm creating here now, without the battery, is coming straight from the alternator. But if I pedal too fast, you'll see some spikes happen here. Right there. So if I keep pedaling at a certain rhythm here, I'll get 14 volts or so out of the alternator. So now my next step is to take that voltage and charge a supercapacitor, which in turn will be hooked to the back of an inverter. Okay, so I got the 58 farad capacitor hooked in here. I left the diode on there just so it's easier to attach to that screw for the time being. And the positive is obviously where the diode is, and the negative right there I tied back into the negative post over here. So I already tested this capacitor. It was completely discharged. There was no volts on here. So now it's getting a little harder to pedal here because there's some resistance with the capacitor. So I'm reading 9 volts here. I'm not sure what the oscilloscope says there. So I'm going to pedal for a little bit, see how long it takes me to charge this capacitor up. My display now says 10 volts. I've got the battery disconnected. So right now I'm reading 10 volts here. Doesn't take me too long at all to bring this thing up to 12 to 16 volts. It is much harder to pedal now. Volts. Okay, let's test the voltage on the capacitor now. 13 volts. So as you can see, it didn't take less than a minute, and I've got this 16 volt supply, 16 volt capacitor charged up to 13 volts. So I took the capacitor off the bike and put it on my bench here, and I'm gonna see how long it'll actually light a 20 watt bulb for. It's a 20 watt bulb, 58 farad capacitor, and this bulb gets pretty warm. So you can see about 30 seconds or less, I charged up this 16 volt capacitor up to 12-13 volts, and now it's got a load on it with a 20 watt halogen light bulb. There's still 12 volts on it right now, so I'm going to let this thing run down and see how long it takes. course, after I see what kind of things I can run off of a small inverter with this tiny capacitor. I shouldn't really say tiny, it's a rather large capacitor, but it's tiny compared to this guy here. So this little beauty is what I plan on permanently attaching to this bike powered generator. And I'm sure it's going to take me a lot longer to charge this up and a little bit more effort, but I'm pretty confident in the amount of current that's going to come out of this thing to surge current wise is going to feed an inverter very well.